Okay, so we're on to the last section of 4.6, which is moving from polynomial equations and rational equations to polynomial and rational inequalities. So we're going to start with polynomial inequalities. So the only difference between an equation and an inequality is that instead of having an equal sign, we have a greater than, or a less than or equal to, or a less than sign, okay? But it's all the same rules apply, like these are all polynomials. Now, to solve a polynomial inequality, it means to find all the values of x that make the inequality true. So this isn't going to be like finding zeros where x equals 4 and 5 and 2. It's going to be a whole range of values that are going to make the inequality true. One thing to remember before we go too deep is that less than or greater than, you're going to be using round brackets because it's not inclusive, and less than or equal to and greater than or equal to, you're going to be using square brackets or closed brackets. Okay, so inequalities. You're going to have wording like where would f of x is greater than 0, or where is f of x equal to 0, or where is f of x less than 0. What does that mean? Well, it says where is the value of your function when x is 0 going to be greater than, or f when, sorry, let me start that sentence again. Where is the value of your function when x is 0 going to, oh my gosh, why do I keep saying this? Where is the value of your function at x going to be greater than 0? Whew. Meaning, when are your y values going to be greater than 0? When are your y values equal to 0? When are your y values less than 0? Okay, now where does that look on a graph? Well, y values that are greater than 0 are anything above the x-axis. All these y values are greater than 0. Anything on the x-axis has a y value equal to 0, and anything below the x-axis has a y value less than 0. So if I give you this graph, and I'm just going to shrink down my screen. Okay, if I give you a graph of a polynomial that looks like this, and I say, where is this function of x greater than 0, greater than or equal to 0, less than 0, and less than or equal to 0, you're looking for values of y. So for this one, it's saying, where is y greater than 0? Well, all of these y values here are greater than 0. All of these y values over here are greater than 0. So how would I show that? Well, I would say that anything to the left of -2 is greater than 0, and anything to the right of 1 is greater than 0. So if I took this onto a number line, I would say, hey, I've got an x-intercept at -2, I've got an x-intercept at 1. Anything to the left of -2 has positive y values. So all these x values give you positive y values, and everything to the right of 1 gives you positive y values. So to write that in interval notation, I'd say it's anything from -infinity up to -2, or 1 up until infinity. If it says where are your y values greater than or equal to 0, the only difference is that instead of using round brackets or open brackets, we're going to use closed brackets or square brackets. So you're going to go -infinity up to -2 inclusive, or 1 to infinity. That's the only change. Then if I asked you where do you have y values that are less than 0, if I look on the graph, all of these y values down here are less than 0. So all of these x values between -2 and 1 give you y values that are less than 0. So if I look at that on a number line, again, you've got that x-intercept at -2 and that x-intercept at 1, but this time it's everything between -2 and 1. So my solution would be -2 to 1. If it was equal to, the only difference is you would use square brackets. Okay, so you're probably wondering why is there this big line here? And I just wanted to say that I want you to be able to see this in a bit of a different way as well. So if I didn't want to do a whole graph, let's say I just wanted to look at the x-axis, kind of like what I was doing here, I could say, hey, there's an x-intercept at -2, and there's an x-intercept here at 1. And then I could say to the left of -2, my graph was above the x-axis, and instead of drawing it, I could just show that my y values are positive. Then between -2 and 1, I could show that my y values are negative, and then from 1 to infinity, I could show that my y values are positive. And I could use this to show the inequality as well, or to solve the inequality. The reason I'm showing this is what we're going to be using when we go to rational inequalities, and so I just kind of want you to see it within polynomial as well, because maybe some people will end up sketching like this. You know, this is kind of a sketch, and you could use it to solve it, just like putting, you know, an actual line on there. Okay, So now let's move away from giving you the graph to saying, okay, now what if you have to graph it? So this first one says, for the function f of x is equal to x times x minus 1 times x plus 1, I want you to solve where f of x is greater than 0 and where f of x is less than or equal to 0. So the first thing I have to do is break my x-axis up. So I've got my steps here. Step number 1 is rewrite the inequality as an equality and factor to find the zeros. Then you're going to plot your zeros to break your x-axis up, and then you're going to figure out where the shape of your graph. When are you above or below the x-axis? You're going to do this with test points, so like intervals, or using the multiplicity rules. And then you're going to look at that graph and determine what are the solutions to this inequality. So let's do that first. The first thing we're going to do is find the zeros. So to find the zeros, I should have set this question up a bit different, but to find the zeros, you set y equal to 0. So when is 0 going to equal x times x minus 1 times x plus 1? So that tells me that my zeros are x equals 0, 1, and negative 1, and I'm going to write them in order. Negative 1, 0, and 1. Okay, so now we're going to plot those zeros on an x-axis graph, meaning I don't need the y-axis. I don't care how high it goes. I don't care how low it goes. I just care if the y values are above or below, so we don't have to be so precise. So I'm going to plot those x-intercepts, negative 1, 0, and 1. Now I'm going to sketch the graph using my multiplicities, or I'm going to test points like f at negative 2, f at negative 0.5, f at 0.5, f at 2. Now, all of these x-intercepts have a multiplicity of 1, which means every single x-intercept is going to cross the x-axis. This is an odd graph because there are 3 x's multiplying together, and it's a positive graph. So it's going to start in quadrant 3 and end in quadrant 1. So I'm going to start down here, and I'm going to go through, go through, go through, and look at that. I end in quadrant 1. Now you can't really see it's quadrant 1 because I haven't drawn the y-axis, but top right, right? That works. Another way of looking at this graph would be to say, okay, I've got my x-intercepts at negative 1, 0, and 1, and I could say, hey, here the graph is below the x-axis. Here it's above, positive y values. Here below, negative y values. Here above, positive y values. And now I can use this to solve my inequality. So this one wants to know, where is the value of your function greater than 0? So where are your y values greater than 0? Well, it's from negative 1 to 0 and from 1 to infinity. So it'd be negative 1 to 0 or 1 to infinity. So we use or because your x values could be anywhere in there. They could be between negative 1 and 0 or between 1 and infinity. And then if I asked you, where is your graph less than or equal to 0? So again, if I looked at it, it's less than or equal to 0 here, right? And in this little section in here, these y values are all less than 0. Or it's where your graph is got negative y values. So the answer to this one would be negative infinity up to negative 1 or 0 to 1. All right, so hopefully you kind of get a hang of it. Now, usually your questions will be more phrased like this. Okay, so instead of having like a function and then solve the function if it looks like greater than or less than and all these things, this is simpler actually. So instead of having to do like 2 different scenarios, this is your function. This is f of x. F of x equal to negative x squared times x minus 3l cubed times x plus 4. This is your function. And it's saying, where is your function less than or equal to 0? So I want you to pause the video. I want you to find the zeros. I want you to figure out the shape of your graph using intervals or multiplicities. And then I want you to see if you can solve the inequality. Okay, so my zeros are negative 4, 0, and 3. And then I got to check my multiplicity. So I have a multiplicity of 1, I have a multiplicity of 2, and I have a multiplicity of 3. Which means my graph is going to cross the x-axis, it's going to touch or just lightly tickle the x-axis, and then it's going to flatten. All right, so what does that look like? Well, let's put our x's on. Negative 4, 0, and 3. I have to know where to start, so this is a 1, 2, 3, 4, 5, 6. So this is a 6-degree equation, which makes it even and negative. So it's going to start in quadrant 3 and end in quadrant 4. So I'm going to start down here, and I'm going to cross, touch, flatten. So cross, touch, flatten, and cross. If I had done this using intervals again, right, you'd have the same x-intercepts, but when you test points, the y values would come out negative, positive, positive, and negative. Now, we're looking where this function is, the value of your function at x is less than or equal to 0, and that is going to be here, down here, or you can see this part of the graph and this part of the graph. Okay, so that's all where it's less than equal to 0, or sorry, less than 0. Okay, this is a tricky one. So these are the two parts that I am less than 0, and if you answered just those, you'd be almost there. Don't forget that this is also equal to 0. So since this is a 0, this is equal to 0. It gets me every time. I always forget that part. So my answer would be negative infinity up to -4 inclusive, or 0 itself inclusive, or 3 to infinity. All right. Last one. So the last one we're going to do, of course, is one where I haven't given it to you in factored form, and you're responsible for factoring it. So how do we do that? Well, first thing we do is we move everything to one side. So we say this would be x cubed plus 4x squared plus x minus 6, and we want to know where is it greater than 0. So we're finding where is the value of your function at x greater than 0. First thing we're going to do is find our zeros. So to find our zeros, we let it equal to 0. And we solve. So now we have to find something that gives us a remainder of 0. So you just have to try. Your possibilities are plus or minus 1, 2, 3, or 6. I'm just looking at my notes here because I don't want to search for a whole bunch. I'm going to tell you that when we put in x as 1, we get 0. So I'm going to do my synthetic division. I've got 1, 4, 1, -6. Make sure you don't have any missing terms. That'll get you on the test. I'm going to carry down the first term, and then I'm going to multiply, add, multiply, add, multiply, add. So that takes my function down to x minus 1 times x squared plus 5x plus 6. And if I'm not being cruel, right, I'll make these nice x-intercepts. So now I can factor that remaining quadratic. So x minus 1 times x plus 3 times x plus 2. Right, these are equal to 0. So then my zeros are x equals, in numerical order, -3, -2, and 1. They all have multiplicities of 1, so they're all going to cross the x-axis. This is an odd positive graph, so it's going to go from 3 to 1. How do I tell it's odd? Odd, remember 3 factors. If I multiply these out, I would get x cubed, or simply look at the beginning. This is your leading term, right? It tells you that you have a 3rd degree equation. Okay, so now I'm going to do my sketch. I feel like my screen's darkening. I don't know if it's doing it for you too. It's getting late. So I have an x-intercept at -3, -2, and 1. I'm going to start in quadrant 3, and I'm going to cross through the x-axis. Or if I had done intervals, right, I could look at the fact that my graph is below, above, below, above. Then I want to answer the question. They wanted to know, where is this value, this function of x greater than 0? So it is greater than 0 from -3 to -2, or 1 to infinity. All right, so that's the first part. So the first part is solving polynomial inequalities, and good luck.